Okay, to insert at the front end yesterday, so we understood. So you don't have to take any additional pointer. So the head pointer itself is sufficient. So since we can traverse in both the direction using the head pointer, it is possible for you to access the first node also and the last node also. And using the head pointer, it was possible for you to insert at the beginning and even insert at the end without taking the additional pointers. And similarly, now we'll try to understand how to delete from the front. Okay, we'll just discuss how to do delete from the front. So you have to give the inputs to me now, because you know how to insert at the end, front end, and how to insert at the rear end. Delete front. Yeah, can you people tell me? So let me write the simple doubly linked list with the other node, and then we will go for performing the delete operation. So this I'm considering it as the head node. Head is pointing to this, and now let me take 2 to 3 nodes. This is another one. So this is the third node. I'm writing one more. So let me consider this as the last node now. Okay. So if you just look into the status, so this is how it looks. And from this node you can reach this. From this you can reach this. And similarly here. Okay, now the left link of the head node will hold the address of the last node. And the right link of the last node is holding the address of the first head node, or you can say the first node. So this is what the status is. Now you tell me, now if I want to delete this node, what are the changes I got to do? So this node I want to delete. So let me write the addresses also. So let me assume address of the header node is 1, and address of this node is 2, address of this node is 3, and this is 4. Now based on these addresses, let me fill the left link and the right link. Okay. Now here in the right link of the head node, how much will be there? What address will be there? 2. In the left link of the node which is at address 2, 1 will be there. Okay. So using this one you can come here, and using this 2 you can reach this node. And similarly, now what will be there here in the right link of the node which is present at address 2, 3. And in the left link of the node which is present at address 3, you'll have the address of node 2, that is 2. And here same 4, and this is 3. Now in the left link of the header node, you have 4, because using the left link of the header node you can directly go to the last node. And similarly, the right link of the last node is holding the address of the first node, that is 1. Is it clear?
Yes, sir.
Yes,
Okay.
sir.
Now to delete this, now what are the changes I got to do? Tell me. To delete from the front. So that means this is the first node now. You got to leave this, excluding this header node. So this is the first node. Now I want to delete this. Now what are the changes I got to do? See here. Now if I'm deleting this, okay, in the right link of the header node, okay, right link of the header now, right now storing the address of this node. Now instead of this 2, I need to write over here how much?
3.
3 I need to write. Correct? Now using head, okay, is it possible for you to access the 3? So using head pointer, this is the only pointer, we don't have any other pointer, yes or no? Now using, my question is, using the pointer head, is it possible to get the address of this node? I hope all of you are observing my mouse movement.
Yes, sir.
How?
Head arrow right link, arrow right link.
Head arrow right link, arrow right link. Okay. So head arrow right link is equal to head arrow right link, arrow right link. If you do, can I know? So this 2 will be overwritten by what? 3. Hope you understood. Yes or
Yes,
no?
sir.
Okay. So now,
Indra,
okay, that is
this
fine.
was-
You can, yes, please mute.
This was cancelled.
Please mute.
I said.
USN 172. Where are you? Okay. So you can update this 2 to 3 by writing head arrow right link is equal to head arrow right link, arrow right link. Okay. Okay, that is fine. You'll write 3 here. Okay. Next what? So you got to write the address of header node where? Address of the header node has to be written here. How to do that? Tell me. See, when you delete this, this is fine. You can write the address of this node here. So as you said, correct? So address of this node 3 can be written here. Now how to write the address of header node here? Yeah, tell me.
Head arrow R link.
Head arrow R link.
Arrow R link.
Head
Arrow L link.
Head arrow R link, arrow L link is equal to what?
Head.
Head. Okay. See, now when you are deleting this, okay, what are the changes you got to do? So this is deleted. So this is the one. This link you have to build. Only 2 links, and this link you have to update. Any other changes you got to do? Any other changes? Just think and tell me. So this will be deleted. After deleting this, how many pointers should be there between this node and this node? 2 pointers. Are they there? Do you have 2 pointers now? So please speak.
4
Hello?
pointers of this.
How 4 pointers?
No, sir. No, sir. 2, sir. 2, sir.
2. See, because we delete this. Now the link has to be defined
Yes, sir.
between only these two. Okay. Now let me write here. So first, what is that you got to do? You got to do this, and next you got to do this link. Okay. Observe now. Head arrow. Head arrow. R link. This field I'm accessing. R link is equal to head arrow. I'm traveling. I'll use head arrow R link. I'll come to this node. Correct, right? This node address. Arrow R link again gives me what? 3. And what is this 3 is? Address of this node. Okay, head arrow R link. So when I say head arrow R link, it is this node. Okay. Arrow one more R link. Semicolon. What is this? It is the address of this node or this field. Head arrow right link. One head arrow right link is 2, and arrow R link again is 3. Now this is 3 now. You are assigning 3 to head arrow R link. Now this becomes 3. That means this link is established and this is broken. Correct now? Next, what you have to do, you got to store address of this node here. How to do it? Head arrow right link head arrow right link is, now you come to this node. See, in this statement, when I say head arrow right link, it is this node. Now after this statement, if I say head arrow right link, it is which node? So it will directly come from this node to this node. Correct, right? Arrow left link. So the head arrow right link. So you're coming to this node. Arrow left link is equal to what it is. What does that have to write? What is that you need to write here? Instead of this 2, what is that you need to write?
Is equal to head.
Head, good. Is equal to head. Okay, then this link is established and this node is deleted. That means deleted in the sense it will be there in the memory, but you don't have the address to reach that node now. The address is lost now. Understood? So earlier you add address in this header node to reach this, and you add address in this node to reach this. Right now this is also updated to 3, and this also gets updated to 1. That means you have lost the address of reaching this node. It's still there in the memory, but you don't have the path to reach it. Correct now? Yes or no? See, when I do this link is broken. This link is broken. This is also broken. This is also broken. But still this address is there in the node 2. The node which is present at address 2. 1 is still there. 3 is still there. From this node, you can come to this node. From this node, you can come to this node. Now this is isolated now. Yes or no? So this is isolated. So because, from this head node you cannot reach. From this node also you cannot reach. What does it mean? Only from this node you can travel. So the other way communication is not possible. So this is something like an island now. Correct, right? So which you cannot travel. From this you cannot travel. Hope you people understood, and nobody is there. And it's something like an island where nobody can go. Correct? If you take a berth there, then you can come to this. If you're not taking the birth in that place, then it is not at all possible for the other people to get into that place. Hope you people understood.
Yes, sir.
Okay. Now, so delete front is clear. Now, same way, so we need to understand the delete rear. Okay, we'll understand. We'll do that. So let me keep this, okay, and open one more. Yeah, it's already there. Okay, insert a text box and delete from the rear. Delete from the rear end. Okay. So you have to tell me now what to do. I'll take an example. This is Z. This is Z. And this is one more node. This is one more node. This is another node. Okay. Somehow my neurons in my brain have learned to write using the mouse. I'm used to it now. Okay. Now. Okay. Now here you have address of this node, and here you have address of this node. This is 1, this is 2, this is 3, this is 4. Okay. Now if I start writing the addresses, 2 here, 1 here, 3 here, 2 here, 4 here, and then 3 here, and this is 1 and this is 4. Okay. Now I want to delete this. Yeah, tell me what I have to do. What I have to do to delete this? To delete this node, you got to modify this. You got to modify this. Correct, right? Yes or no?
Yes, sir.
So this one, you make it to point to this. So that means in the left link of the head node, you got to store the address of this node, and in the right link of this node, you got to store the address of head node. That's all. So that solves your job. If you're doing that, what happens? So this link is broken. Okay, this link is broken. That means from this node, so you cannot reach this. From this node, all the way you'll go back to head, and from the head, so you will not come to this. You'll come back to this. This node you'll reach. Yeah, tell me the programming statements now to do this. Yeah, tell me what to do now. So go for replacing 1. Yeah. Now when yeah, let me show you. So when you delete it from the front, okay. So first you updated the right link of the head. Correct? When you are really deleting from the rear, you got to update the left link of what? Head first. Understood?
Yes, sir.
Yeah. How to do that? Add arrow left link, correct, right? Add arrow left link is equal to what?
Head arrow L link. Arrow L link.
Add arrow L link, arrow L link.
L link.
This field you are accessing. Hope you people understood? Add arrow
Yes, sir.
L link. Where I'll come? I'll come to this node. No, I don't want. I'm not interested in address of this node. I want address of this node. Where is this address? Here. Add arrow L link will bring you here, and again one more arrow L link will give you this. And this you assign it to add arrow left link. Okay, and this 4 will change to 3. Okay, now let me write add arrow L link is equal to add arrow L link arrow L link. Okay, so this add arrow L link is nothing but 4, and the node 4 arrow L link. Okay, this is nothing but 3, and this 3 you are assigning it to the left link. Now this 4 will be I am writing here only, up I'll write change to 3. That means this is no longer pointing to this last node. Now it is pointing to this node. Correct, no? Correct, no? Deleting
Yes,
now is nothing but deleting the incoming node, incoming links to the node which you are deleting. Okay, so this was incoming link. Okay, this was one incoming link. I have deleted this and I have redefined one more new link incoming. Correct? That means nobody should come to this place. Okay, and there is one more link now. So I can go to this node still from this 3 to 4 I can go. Now I want to redefine this also. How to do that? So here instead of this 4 I need to write how much? 1. How to do that?
1.
Yeah, how to do that? Address of add node I need to write. Add arrow L link.
Arrow L link. Arrow R link is equal to head.
Add arrow L link. Okay, L link. Now add arrow L link, when I say I have the new path now, it comes to this node. Now in this node, which field? Again R link field. Arrow R link. R link is equal to, what is that I need to write? Head. So this 4 is removed and 1 is written here. That means from this node you cannot go to this. Now from this node, where you will go? To this. So it's already there. Understood? Yes or no? See, incoming links to this node is updated now. So that means it's not possible for you to reach this. This is an unreachable node now. Is that clear?
Yes, sir.
Okay. Unreachable node, and if you want to free the memory also, you can free it, not an issue. Okay. So to free the memory, what you have to do, you need to take one more pointer and make the pointer to point to it and just say free. Say for example, before doing this, is this node, before executing this statement, is this node reachable from head? Yeah, answer me. Before doing this statement, listen to me. Before doing this statement, what I have written here, is this node reachable from it?
Yes.
Yes.
Yes,
What you
sir.
do is, say I don't, sir, I don't want this node to be present inside the memory. I want to remove this from the memory. What you do? Add arrow. Take a pointer. Say for example, I take one more pointer PTR. I'll just say PTR is equal to head arrow. What is that? Head arrow. Left link. L link. What's happening now? This PTR is pointing to this. So PTR is pointing already. Now you say free after doing these two statements. So before these two statements, just write this statement. Make PTR to point to this. Now you say PT free PTR, and this will, correct, no, get submerged in the sea. This was an island. The moment I say free PTR, so the entire island, so what, it will get submerged in the sea. Is it clear? Yes or no?
Yes, sir.
Okay. So
Yes,
till
sir.
now, till now, all things you understood. How to insert in between, okay, and then how to insert at the front, how to insert at the rear end, how to insert delete from the front end, how to delete from the rear end, and even you also learned how to delete from the middle. See, this is how you do it, deleting from the middle. Okay. Now, so next is the circular linked list. Okay. So since you have already understood the doubly linked list and its concepts, and you know how to delete and insert from the various positions or the places, now circular linked list is not at all a difficult thing. Okay, it's very easy. Only thing is two-way movement is not possible. Okay, observe here. So I have a PTR. This is one node. So this is so I have two info fields here. Okay, two info fields, and then this is the link field. So link field, and again the last node is holding the address of the first node. Okay, now so I need to take few more examples on this circularly linked list. I'll take them in the next class. Okay. Again, how do we insert at the front for the circular linked list? How do we insert at the rear for the circular linked list? How to insert at the middle? How to delete from the front? How to delete from the middle? And how to delete from the rear end? So same thing we'll be discussing again for the circularly linked lists also. So any doubts till here?
No, sir.
Okay.
No, sir.
So now, so let me discard everything. And it was a lab tutorial. I could not start with the lab program today because I had to complete few more things. So now I have completed delete rear and delete front, everything. Now I think I can show you the lab question. Say, I am proctor for which batch students? I think C3 batch, no? Any C3 batch students are here? Please speak. C3 batch students are here?
Yes,
Yes, ma'am. So I'm not able to hear you. Please speak louder. How many C3 batch students are here? Can one or two speak with me? C3?
Yes, sir.
Yeah. Am I your proctor?
Yes, sir.
Okay. So I'll be calling a meeting for the C3 batch students today evening. Okay. After I reach home, I'll be calling the meeting for all the C3 batch students. Lab is there, no? Lab portal. You'll connect to the lab, no? DS lab. C3 batch
Yes,
students. Okay. So I'll arrange the meeting in that. Okay. Today we will. Shall we have it at? I think by 6:30 I'll reach home. Yeah, I'll put a message in the group.
Okay, sir.
Before half an hour before, I'll put the message in the group. Just if you any one of you see the message, so please inform all your friends from C3 batch to connect to the meeting. I
Sure,
think
sir,
by 6:30 or 7 I'll arrange the meeting. Okay. Okay.
Okay,
Now,
sir.
okay. Yeah, and one student was asking about the Python and the materials I had shared with one student. So now today I have uploaded even the Python application development using Python recorded videos also, my own recorded videos to the YouTube channel. If you people are interested, and the student who I don't remember, who had asked for the materials on the Python, if you are there in the class, after the class you can just WhatsApp me. I'll share the YouTube channel link to you, so you can go through that.
Okay, sir.
Okay. So what's your name?
My name is Sanjita, sir.
Okay, Sanjita, I'll share you.
Okay, sir. Thank you.
Okay.
Excuse me, sir.
Yes, ma'am.
Sir, USN 158 has doubt.
Yeah, tell me.
In chat box, yes. Sent message.
Yeah, in chat box you sent. Okay. I'm opening it. One second. Okay. So the deleted node, you said it stays in the memory. What to do if you don't delete it from the memory? Yeah. See, it stays there until you shut down your system. Until you turn off your computer, it will be there. The moment your computer, once you restart, RAM is a volatile memory. So it's not there in the hard disk, it will be there in the RAM. So the moment you there is no power supply to the computer system, everything which is there in the RAM gets what? Erased, because it's a volatile memory. Okay. And one more is, sir, the internal starting from the 11th or the 12th? 11th, from 11th it is. Okay. Now, is that clear? Is the doubt cleared? Hello?
Yes, sir.
Yeah. See now, the question And now you have understood everything, all sorts of doubly linked list you have understood, and now this program I think it won't be difficult for you people. Okay, so the 8th program is on that itself. Okay, so design, develop and implement a menu driven program in C for the following operations on the doubly linked list of employee data with the fields, the same fields which we took for the singly linked list is also considered for the doubly linked list, but there is one more additional field. Yes, and this since it is employee, this was a student and this is employee. SSN is their name, department, designation, salary and phone number. So these are the information fields. Create a DLL of n employees by using end insertion. Now you understood how to do the rear end insertion to the doubly linked list. Display the status of DLL and the count the number of nodes in it. So and then perform insertion and deletion of at end of the DLL. Okay. So when you're creating the employee list, you got to do at the rear end, and after that you should also demonstrate how to insert and delete at the end of the DLL, and then perform insertion and deletion at the front of the DLL. Demonstrate how this DLL can be used as a double-ended queue. Here we demonstrated how the singly linked list can be used as a stack, by performing the insertion and deletion from the same end. So even this singly linked list can be used as the stack. In the same way, so the doubly linked list can be demonstrated to be used as a double-ended queue. I hope you people remember when we were discussing queues, we understood various types of queues. We understood circular queue, we understood D queue. D queue is nothing but what? Double-ended queue. You people remember that? And then priority queues we understood. Do you people remember all these things? Double-ended queue, priority queue, circular queue. So I need your response. Yeah. So now that is what we demonstrate. So we demonstrate how the doubly linked list can be operated as a double-ended queue, and then finally the exit. So this I hope all of you can try to implement this program now. So because most of the things you have understood, okay, everything related to that is clear. So only thing is you need to start implementing it. So whether it is right or wrong, at least you should make an attempt. So because with that you'll learn how to do it. And the next program again is based on a singly circular linked list, SCLL. So that is with this concept. So this concept. So here I need to take few more examples. So let me take up that in the next class. Okay. So now, so I want you to do this. Create a doubly linked list of n employee data by using end insertion. Just write a function to do this. So first you write a function to create a node. So you can refer your previous program for that. Okay, the singly linked list. Now a singly linked list, we had declared a macro called as malloc, and that macro we used to call from the create function. So just refer that, and in the same way try to write, okay, this function now. So you can easily do that. So this is not at all a difficult. If you have understood the singly linked list and understood what all the operations what I taught you people now, so this you can easily do by yourself. Okay. So I'll be giving this program, but not now, because now I cannot complete this complete program, because to complete this and explain and performing the debugging, at least I need 1.5 hours. So now I want you people to try with this. Make a try, even in a sheet of paper you can start writing and share it in the WhatsApp chat group. Sorry, not in the WhatsApp chat, in the Teams chat box. So please don't sit idle. Take a piece of paper, and you already have this program. Okay, so there malloc is also there, create is also there. So same way you try to create a doubly linked list of n employees data by using end insertion. End insertion I've already explained you. Start doing fast, quickly. Let me see how you people will make an attempt to do it. Can I know how many of you have started doing it? So can I have quick response from you people? Yeah, start. Only one response. What about others? Can I hear something mass from you people? Yes sir, we are writing. Can from all of you? Oh, again only one. Oh, 2, 3, 4. So how many are there? 46. Now heard only from 5 people. What about the others? Other 42. So once again, please all of you, can I know? Say, sir, we are doing it. Let me check how many of you will say. Are you people writing? Okay. You're trying. Okay. So again the same 3 voices I could hear. No new voices. Okay. Open this program. Open the 7th program, and the same way you try to make an attempt. So if you make sincere attempt now, correct. So once I explain the program, you don't have to spend more time for learning this program. Okay. So within no time, when I'm explaining the program, simultaneously you'll understand it, and so that after I finish, you'll be in a position to write on your own. So make it fast. So write in a sheet of paper, take the pic and post it here. So meantime, I'll finish taking the attendance. So while taking attendance, let me pass this. Please, have you done? So it should not take much time. I told it similar to the singly linked list. Only thing is double links you have to do. Anybody finished? Who has finished writing at least 80 to 90%? So don't hesitate. Whatever you written, you share it. Let me check. So in a sheet of paper, if you have written all these things what I explained, Karina, then it will be very easy for you to do it. Yes? I didn't get any response. Are you people there? Yeah, then do it.